Now we're moving on to the third video of this unit, so it's unit 4C. And we're going to be setting up and completing ratio tables. All right, so you're going to be given a table for two values, and you're going to have to complete any of the missing values using ratios. So the first learning objective is obviously know how to complete a table using ratios. Right? So I'm going to show you one particular way today. And in class, we can talk about another way, and we can talk about maybe some other things that you could see to help you fill out these ratios. But I think knowing what a proportion is and knowing how to solve for ratios using a proportion, I think is the most direct and easiest way. It's the least amount of logical thinking that you may have to do, and you can follow the same steps for every single problem. So because of that, that's all I'm going to show you in this video. And then from there, you guys, once we start talking about it in class a little bit more, you can use any method that you want. All right, but I'm going to just show you one particular way every single time when we're completing these tables. And some of you might be able to fill out these ratios without needing to do this method, and that's fine if you can see that right away. But just make sure that you're checking your work with the answers I'm getting as well. And there's different ways you can go about solving this. But I'm going to use proportions because we're going to learn it very soon anyway. It's something you have to be able to do. And then also it's the most direct way of solving. And then after we know how to set up and solve these tables, we're going to know how to solve ratio word problems using ratio tables. All right, so we're going to continue to do word problems, but this time we're going to use ratio tables to solve them instead of the tape diagram. All right, so this whole video is just going over a bunch of different problems, so it's probably going to be a little bit longer, so just bear with me, but it's just going over how to solve problems. All right, so for each of these problems that we're going to do, there is going to be a and B. All right, so for this first one, what I'm going to suggest is you take the smallest two different numbers that we have. So in this case, our triangles and number of sides. So we're going to take our smallest ratio. So we're going to create a ratio for this, 1/3. All right, and then what we're going to do in order for us to solve for these missing parts, and like I said in class, we'll talk about another way that you can do this. But for now, we're just going to use these ratios. Is we're going to create the proportion. But what a proportion is two ratios that are equal to each other. So that means I'm going to set this ratio equal to another ratio. Well, we have to stay consistent. Since this 1 represents the number of triangles that we have, and this 3 represents the sides, when we create our next ratio, we must do it in the same triangles to sides. So that means it will be 2 over. Well, we don't know what this value is. It's unknown. So how do we represent an unknown? I'm just going to put X, right? And then now, something that I showed you guys before, but if we know that two ratios are equal to each other, 1/2 is equal to 2/4. You should all know that. One of the ways that we can check our work is we can do what's called cross multiplying. 1 times 4 is equal to 2 times 2. So 1 times 4 is 4, 2 times 2 is 4. So when we have a proportion, our cross multiples, it's called our extremes and our means. You don't need to know that right now, but in the future, like in 8th and 9th grade, you will. They will be equal. So to solve for this missing value, we can cross multiply. We can do 1 times x is then equal to 2 times 3. Well, 1 times x is this x, and 2 times 3 is equal to 6. So that means that this missing value is 6. All right, and now I can keep thinking I can solve this again by setting up a ratio or a proportion. So 1/3 is equal to, well, I don't know this number here, so I'm going to use a different variable. Don't use x because we've already used it. Y/9, right? And then you can solve this using any way that you want it, that we've learned already this chapter. And that's because we have learned different ways to complete these ratios. Well, 3 times what gives me 9? 3 times 3 does. So I can also say 1 times what gives me, or 1 times 3 gives me what? And that means that in this case, y is going to be equal to 3. So that means that my answer here, let me just erase this blocked edge so I can fit it in. That means that this answer here is going to be 3. And we can check our work. 3/9. Does this reduce to 1/3? Yes, it does. All right, so we can use our proportions and cross multiply to solve, or we can use any other method that we've learned how to solve for this. In this problem, it's probably easier for you to use the second way that we just discussed, and this is another way that we have done earlier this year. All right, so I'm going to do this third one off to the side over here. We have our same ratio of 1/3. It's then going to be equal to 4 over z. Well, 1 times what gives me 4? Well, 1 times 4 gives me 4, so that means I will do 3 times 4 to solve for z, and z must be equal to 12. And then we can check our work by 4 over 12. Does that reduce to 1 over 3? Yes, it does. All right, so here we were solving the first one. I showed you how you could use a proportion, but then this one was easily set up since this ratio is equal to 1 that you could have used any method that you want. It is completely up to you. All right, now let's move on to the next problem. All right, now for this one, same thing. We have to solve for these missing parts. So you could do this. I guess I can show you one way right now, is we can quickly and easily solve for this one. Well, let's just write it out. We have our ratio of 4 over 6. It's going to be equal to 20 over x. It's our first one that we don't know. Well, I can solve by cross multiplying if I wanted to. But if I can quickly see, well, 4 times what gives me 20? Well, 4 times 5 does. That means I can quickly solve for x by knowing that 6 times 5 will also have to give me x. And 6 times 5 is equal to 30. So I can quickly solve for this one here by just multiplying. All right, so now I move on to the next one. 4 over 6 is equal to y over 90. Well, maybe it's not easy for you to identify what 6 times what gives me 90. So before we do anything, what I would suggest is simplify this ratio as much as you can, right? Because the more that you can simplify in the beginning, the smaller the number is going to be that you're going to have to work with, which then is going to make it easier for you to multiply and easier for you to divide. All right, so now we can reduce this 4 and 6 because we know that they're both divisible by 2. So I can divide both of these by 2. So this gives me 2 over 3 is now equal to y over 90. All right, so now maybe something jumps out at you. But if it doesn't, let's go ahead and show you again how to use our proportions and solve for them. So we can cross multiply. So 3 times y is equal to 2 times 90. Well, 3 times y is 3y. 2 times 90 is 180. We can divide each side then by 3. And y is then going to be equal to 60. So I can then write 60 there. Now, these x's and these y's are not referring to x and y that you would have on your coordinate plane. So hopefully you guys are able to identify that right now because right now we're just using any variable to solve for this missing part. All right, so then our third one that we're going to solve for, we already know that this ratio is going to reduce to 2 over 3, so let's just use that. So 2 over 3 is then equal to, let's say, z over 180. Well, maybe now you know that 3 times 60 is going to give me 180, so that means I can solve for z by doing 2 times 60. And 2 times 60 is going to give me 120. So z is then equal to 120. So you see there are different ways that you can go about solving for this missing piece of your table. And I don't really care which way you do it. It is completely your call. The one thing I forgot to do in the other question, but let me go ahead and do it now, is it says, then write the equivalent ratio. So the equivalent ratios is 4 over 6 and 20 over 30 and 60 over 90 and 120 over 180. All right, so those are all of our equivalent ratios. All right, so this next one, I'm just going to go ahead. We're going to solve it very quickly and easily because if you see here, at least the first couple, we can just quickly see that we're timesing this by 3 and timesing this by 3. So as we've already discussed when we're dealing with our ratios, when we're multiplying there, you know what you do to your one part of your ratio, you have to do to your other when you're multiplying. So that means I can solve these two quickly by multiplying them by 3. And 1 times 3 will give me 3, and 3 times 3 will give me 9. All right, you could have broke them out piece by piece like we did in the other ones, but it was completely your call as to how you want to solve this, and I'm just showing you another way that you can do this. But if you notice, this one here, it's no longer following that times 3. So I am going to rewrite this and set this up as a proportion to solve. You might be able to figure out what this is going to be based on just these numbers that we have, and this 1 and 100, this 3 and 300, this 9 and 900. So maybe you can guess what this missing piece is going to be. But I'm going to set up our ratio because I see it's no longer following that same pattern. It's now subtracting by 1. So I'll set it up 1 over 100 is equal to 8 over x. Well, in this case, I can see that 1 times 8 will give me 8. So 100 times 8 is going to give me my x, so that means x is going to be equal to 800. So I could quickly and easily solve for that one. All right, I'm not going to write out the equivalent ratios right now just because this video is taking a little bit longer than I was hoping. Even though I know this is going to be long, this video is still already longer than what I was expecting. So you would write them out though, but I'm not going to write them out for any other questions. All right, so let's go ahead and solve this one. So I'm going to do this first one very quickly because hopefully you can see now that this is going to be times 2. So we know that we can solve this one by doing times 2. All right, and then I'm going to show you another way that you can do this quickly as well. Look at these two here. We see 6 to 2. Well, we can also do division. 6 divided by 3 gives me 2. So that means I would do this one divided by 3. And this will give me 2/3. Let me just show you, though, how this could work using our proportions. So we will have the ratio of 3 over 1 is equal to, well, here we have 2 over x. So to solve, we will cross multiply. So it gives me 3 times x is equal to 2 times 1. Well, 3 times x is 3x. 2 times 1 is 2. We divide each one here by 3. So that means x is going to reduce to this 2/3. We're not going to write this as a decimal. We will just leave this as a fraction. So that means it's 2/3. All right, so now let's go ahead and solve this last one. So we have a ratio of 3 over 1 is equal to y over 5 over 3. Well, I can see, I know 1 times any number is itself. So that means if my answer gets to 5 over 3, that means I needed to do 1 times 5 over 3 to get to there. So then to solve for my numerator, I will also times it by 5 over 3. Now, I'm going to do this work off to the side. So 3 over 1 times 5 over 3. Right, remember that we can rewrite these now on one fraction. So 5 times 3 over 3 times 1. And now anytime that we have the same number in our numerator and denominator, we know that they can reduce. So 3 goes into 3 once, 3 goes into 3 once. So now I'm left with 5 times 1, which is 5, and 1 times 1, which is 1, or 5 over 1 reduces to just 5. All right, you could have done 5 times 3 is giving me 15. Let me show it up here. And 1 times 3 is 3. And then you could have did 15 over 3 reduces to 5 over 1. It doesn't matter which way you do it. You still get the same answer either way. All right, so that is it now, just solving and completing these tables. Now we're going to go ahead and solve some word problems. All right, so for this next one, it says, this is number 3, it says a nutrition label shows that there are 75 milligrams of sodium in every 12 crackers. You eat 30 crackers. How much sodium do you consume? So I first created this table where I see that I'm talking about sodium. My ratio is going to be sodium to crackers. So I created this table to go through the different scenarios that we have. So it tells us 75 milligrams of sodium for every 12 crackers. So that was the first thing I filled in here, 75 milligrams of sodium for 12 crackers. And then it says you ate 30 crackers. How much sodium do you consume? So I knew that I ate 30 crackers. So the question I'm trying to solve for is how much sodium did I consume? So the first thing I'm going to do is take this sodium to crackers. I'm going to make a ratio of 75 to 12. Right? I'm going to reduce this ratio as much as I can when I'm going to use this to solve for my other answers. So I know that 75 and 12, they're both divisible by 3. And I'm going to reduce this to where 75 divided by 3 is 25. 12 divided by 3 is 4. So 25 over 4 doesn't reduce anymore. So I will then create my ratio. 25 over 4 is equal to, well, I don't know how much sodium I have, but I do know how many crackers. So it's going to be x over 30. I'm going to cross multiply to solve for this. So we would then have 4 times x is then equal to 25 times 30. Well, we would then get 4x is equal to, well, let's go ahead and multiply 25 times 30 off to the side. So we get 0, 0. We're now going to put a 0, another 0 here because we're moving to the next place value. 3 times 5 gives me 15. 3 times 6 plus 1 gives me 7. So that gives me 750. So I know that 4x is then equal to 750. Well, as we've been doing a bunch right now, how do we solve for x? It's being multiplied. Well, to get rid of multiplication, we will divide. So x is then equal to 750 divided by 4. So let's go ahead and do 750 divided by 4. Well, 4 goes into 7 once. Subtract. Gives me 3. We drop down to 5. 4 goes into 35 8 times. So that gives me 3. We can then drop to 0. 4 goes into 30 7 times. So that gives me 28 minus. And then now we're moving to our remaining parts, so we can add this decimal with this 0. We can drop down to 0. 4 goes in 25 times. So that means X is equal to 187.5. So that's how much sodium you consumed, is 187.5 milligrams of sodium. Okay, this is actually going to be the last problem that we do because this video is getting quite long. We're going to start with this problem though in class, next class, because I'm going to show you another way that you can do this. All right, so I showed you using a proportion. I'm going to show you another way that we can use this table a little bit more than what I just did right there. All right, so that is going to be it for this video. And a question that we were going to do in this video last, we're just going to start with next anyway. All right, so that's it.